Amazon Web Services consist of multiple physical locations called regions. Regions are the physical data centers located all over the world, allowing AWS users to benefit from lower latency by deploying their services to the closest and most convenient location. So if I'm living on the East Coast of the US, I might choose from US East 1 or US East 2. And then when I'm living somewhere in the Europe, I can choose one of the Europe location. Different AWS regions have different set of resources, offer different set of services, and might have a different pricing policy. So when choosing AWS region, we considering multiple characteristics and making decision based on that. In this video, I will explain you what is AWS region, what it consists of, and how we can use it in the way that will increase the reliability of the services as well as performance. Let's zoom into one of the services. So let's zoom into one of the regions and explore what is inside of it. The physical structure of each region consists of multiple availability zones. They are usually named with the letter suffix of the region. So for instance, US East 1B, 1C, etc. So availability zones are physically separated hardware pieces within AWS data center, AWS region data center, that allow us to reduce potential downtime during server instability. Sometimes when we deploy an EC2 instance in the most trivial way, we might not be caring about availability zones. We just choosing AWS region, creating an instance, choosing the default VPC, and AWS just chooses the random availability zone for us because we might not care about that deep reliability. However, if we want our service to be like 99.999% available and we have some SLA agreements with our customers, this is something that we might want to beware of. So we always know that nothing is permanent in this world. Even the hardware, especially the server hardware that works on the really hard load. The storage disks, the computing machines, they are all getting worn off. And considering that this is server that processes like billion of requests per day, the hardware will drain away faster. For that reason, AWS introduces multiple availability zones. So whenever some hardware breaks, it not makes the entire region to go down, because making the entire region to go down gonna have bad consequences, first of all, between AWS and their customers, and second of all, between AWS customers and their customers. That's why AWS gives us an option. If you don't care about your SLA, we will randomly choose the availability zone for you. If you care about your SLA, you can create the cross availability zone deployment that will deploy your service automatically to the available zone. And when the availability zone has downtime, it will move the deployment of your service to another availability zone that is available. The difference between AWS region and availability zone is that AWS region are completely isolated physical scopes. They have nothing in terms of networking. However, they can still be network interconnected. While availability zones are usually located within one data center, but they physically isolated in the data center, they still share the same network. So now let's talk about how the availability zones and regions are utilized in AWS. So by default, when you create your AWS account, you can choose the region, the drop-down menu on the right-hand side, basically. And this is where you choose the region you want to deploy your services to. So we're talking right now about the region as a physical data center. However, we understand that AWS has a lot of clients and each client has a completely separated environment. So whenever I'm deploying my services to AWS region, I can't in any way find IP address or communicate to the services of any other clients. So these services have really strong isolation, and this isolation is achieved by virtualization. I'm not going to be covering virtualization in deep details in this video. However, if you want to learn more about virtualization, how it works and what are benefits from it, make sure to subscribe to my channel, as I will release the next video about virtualization so you don't miss it. And AWS has something called virtual private cloud. And I have another video about virtual private cloud. So if you learn more about virtual private cloud, please find the link in the description below. In virtual private cloud, this is our private virtual network. This is where we deploy our services, our EC2 instances, any kind of AWS services, and set up how they communicating in terms of networking. So how it basically works. This is the US East 2 region. It's a physical region. So this is our example of US East 1 region. This is the physical region with physical subnets, and we don't have access to the host physical, like to the host operational system. So let's consider this subnet as a set of computers, set of servers with networking hardware, and these computers have their operation systems, and we don't have access to the host systems. Instead, AWS creates a virtual network on it. So AWS has its own physical network where all of their routers, switches, and devices are built this network between their servers, and we don't have access to it. We don't know anything about this network. But what AWS exposes us, what it rents out to us, is actually the virtual network. And virtual network is a subnet. So we can just draw it over here like subnet. And our subnet is just a virtual network that exists within availability zone. And subnets belong to the VPC. And I'm actually drawing VPC outside of this region circle because VPC itself, it's just an abstraction. What that VPC means, VPC is just a collection of subnets. So we're using VPC to only figure out which subnet belongs to which VPC and thus AWS account. So let's say I created my AWS account. My AWS account has a default VPC, and this VPC has the subnets that are created in every availability zone. So now if I want to deploy my EC2 instance, I'm deploying it to one of the subnets. In the settings of EC2, I can set up explicitly to which subnet I deploy. Otherwise, AWS will choose a random one. Let's say there is another user who just opened AWS account. Let's call it AWS account 0, AWS account 1. And this account also has VPC. And basically, this VPC also has a set of subnets. So now this user, everything he deploys, it is located in these subnets. And the AWS account, VPC, and subnets, those are the virtual entities. But the region and availability zones, those are the actually physical hardware entities. So they are bounded by the physical hardware. Now, if I deploy multiple services to multiple subnets, they can still easily communicate with each other. So it means that I can literally connect these subnets together because they are set up in the way that allows them to interconnect with each other. Now, know what VPC is. VPC is just this box that connects multiple subnets together. The same happens to another AWS account. And this VPC creates the isolated networking scope for the subnets, and this is how it works within AWS region. However, each account can have multiple VPCs. We are not limited to have one VPC. We can create as many VPCs as we want. So now my account 0 has another VPC, and those VPCs are completely isolated. There is no way service from the subnet US East 1 availability zone from the first VPC can communicate with this one. There is no way. These VPCs are isolated. However, we can set up communication between those VPCs, but it's a completely different topic that I won't be covering in this video. So if you're interested in learning more about it, make sure to subscribe, and I will definitely share the video soon about the ways to create a networking communication between multiple keys. So why do we need this complexity anyways? First of all, the main reason we need this complexity is because of reliability. As I already mentioned, everything warns out. So the same way each network, each server, each computer warns out. Of course, we're doing our best to predict it and replace all the network components as frequent as possible. However, we never secured about some unplanned outages. Let's say we're running a business that brings us multiple $1 million per day. It's hosted in US East 1. And if US East 1 is down, even for a couple of hours, we have a losses for about hundreds of $1,000s. So we have those losses, and we go to AWS and say, AWS, we have this service level agreement with you about 99.999% uptime, and now we have 2 hours of lose. So please compensate us our more than couple of $100,000 what we lose because your services were out. And to avoid it, AWS created the thing that tells their customers next. So we're giving you multiple availability zones. They actually give like the 5, 6, 7, I don't know. It's a physical zones. And it's like really very, very unlikely that all of them will go down. It's impossible. Well, sometimes it might happen. We never know. If the nuclear explosion happens in the city where the data center is located, yeah, everything went down, right? But this is so rare probability of it, so we never know. We're talking about some more frequent use cases where some network issue, some hardware issue, anything like that. Or maybe some overload, maybe some rapid traffic spike that AWS was not prepared to, makes this availability zone unavailable for some certain time. So AWS needs to manage traffic. And AWS brings us the interface where we can set up our services in the way so we can utilize multiple availability zones within the region. And this is much easier to do when we're running Elastic Container Service, because Elastic Container Service allows us to have multiple subnet selection and our services executed in the subnets that are available. And if it happens that US East 1A availability zone is down, all of our services are quickly moved to the US East 1B availability zone. And as far as it's just a virtual, our services are virtual. It happens so quick, so it almost has no downtime, and our services continue functioning until AWS fixes the issue. So this is the main purpose of this complexity of this AWS region structure that we have. It's called redundancy. So we can have our deployment running reliably and everyone is calm about the reliability of our services. But yeah, this complexity might not be relevant for most of the people, for most of the startups. This complexity is usually relevant for bigger companies that have really strict service level agreements with their clients, and they value every second of the uptime and every second of the downtime is unacceptable. So that's why they're considering such a complex infrastructure. But when it comes to most of the startups, there are no SLAs, they're just MVPs that might be creepy, that might have bugs, and this is not something they should be worried about when starting the startup. So that being said, I'm curious to learn more about the size of your current startup or software product. So please let me know in the comment section below how many users are using your software product right now, or at least how many users you're planning to have in your product for the next 4 months. Based on that information, I'll be able to find out, to share with you the cloud infrastructure tutorials for your company size specifically. Also, if you're curious to learn more in-depth practical details about AWS networking, I would highly recommend you reading this book. It's called AWS Networking Fundamentals by Tony Passinen. So this book provides a good practical guide about how to build virtual data center into the AWS cloud specifically for the needs of your software product. You can find the link to this book in the description section below. So thank you for watching. If you want to watch more, please follow the link in the description section below or click on the video that will appear on your screen. Thank you so much, and if you like this video, click the like button.